Rahman Rahim. Today we will discuss electricity. First of all, we'll discuss static electricity and electrical potential. Electricity comes from the word electron, which is a Greek word from ampere. Ampere is material whenever it's been rubbed with another substance, for instance, plastic. Some of the electrons goes from one subject to the other, creating a potential difference. This creates what we call the static electricity, which is the source of alienation and fear of explosion whenever there is inflammable anesthetics. Conductors, insulators, and semiconductors. This is a classification of materials regarding the easiness of moving of electrons through it. So, of course, we have conductors, which are most of the metals, and carbon and saline can conduct electrons easily. And then we have the insulators, which find very resistant to move their electrons through them. And then we have what we call the semiconductors as the thermistors, the transistors, and diodes, where they need some sort of an extra energy for the electrons to move. And we utilize this in instruments as a thermometer, where thermistors, whenever they conduct heat, the electrons are being moved, creating a current, so measuring electricity. Now we come to what we call heat production and alternating current units. Before this, I'm sorry, we're going to discuss the current flow, energy and production, energy production, and volt. We can see from the diagram, which will be, I will show it later on in a bigger figure, where we can define the meaning of the volt. The volt simply is a potential difference whenever 1 ampere is being applied to the circuit, creating an energy of 1 watt. So we have an example of a circuit where we have an amount of current, which is 4 ampere, and this will yield around 96 watts. So we can figure out the potential from dividing both of them, and this is the definition of the volt, the potential, see from this figure. Now we come to the heat production and the alternating current units. Of course, alternating current, it depends upon creating a sine wave. You see, it creates a sine wave. And whenever I want to evaluate the current, I must put in my mind that its heating effect, so that I can benefit out of it, you see. So the alternating current has a peak effect. It goes upwards and downwards with a peak effect, creating sine wave. On the other hand, the direct current is going straight forward, you see. So whenever I want to compare both of these currents regarding its heat and energy requirement, I create what we call the RAM. The RAMs means that I put the two currents. I want to make a correlation between the two types of the current. You know, of course, I forgot to tell you that alternating current, the current goes in one direction and then it is being reversed. On the other hand, the direct current goes in one way. So this is the difference between both of them. So direct current, as we can see, goes in a straight line, and alternating current goes in a sinus way where there is a peak. So I want to make a correlation between them. So I use what we call the RAM. RAM, what's the meaning of RAM? I first of all transfer this sinus wave, which has a positive and negative, into positive by squaring it. And then after squaring it, I create the mean of it. And then after figuring out the mean, I create the square root of it, and we can compare the two types of currents similarity so that I can compare both of them. Of course, this heat is created from the current is utilized in fuses. Special fuses are correlated in the course of the current so that they can cut the current whenever they melt from heat. Electrical burns, of course, can occur apart from the electric quotient, in which the high current can induce burn, especially in tips where the current density is very high. You can have a burn in, suppose, in your ear lobule or your fingers. The surgical diathermy simply is utilizing the current which has a very high frequency up to 1 megahertz. Of course, as we know that the current in milliamperes or the frequency of 40 to 50 hertz are capable to induce electric quotient, but regarding the diathermy, the high frequency is being utilized not to induce what we call the electric quotient, but induces the heat character which we utilize in diathermy. So the monophasic diathermy is made of two parts: an active part which is handled by the surgeon, and the plate, the neutral part, which is attached to the patient. Of course, the active part, which in which the current density is very high, induces coagulation and heating, and this is the aim of it. And on the other hand, the plate, which is attached to a wide area of the patient, the current density is high so that it does not induce any injury. Of course, if we have a fault in which the plate, the neutral plate, is not well attached or detached completely from the patient, the current needs to pass from the active electrode to find a way to go out. So it can go through the patient where he touches objects as the table of any substance which is earthed, and at the same time it can go through the electrodes, and this is why the electrodes ought to be away from the diathermy, the plate, you see. And of course, imagine that the electromagnetic wave can go through the patient without touching the patient, and it can go through implanted metals in the human being, which the resistance is low, and it can go, of course, through it can create problem with the pacemaker, as we said before. Of course, there is another type of diathermy, which is the I'm sorry, the bipolar, where the diathermy, the active, we don't have a plate, and we have of course we don't have a plate, so we don't have earthing. We have some sort of a tooth. This tooth has two parts. The current goes through them, so it does not create problems as the monopolar, and it's reliable in neurosurgery, so that I can be precise on the area where I'm going to use the current. But it is unfortunately is not beneficial in large surgery where we need monopolar current to induce a proper coagulation. Capacitance is the ability of the object to hold electrical charges of electricity. See, the systemic international system of it is the column. The column is the quantity of electric charge which passes some point when the current of 1 ampere flows for a period of 1 second. This is the definition of column. So it is ampere times second. Of course, we know ampere, the amount of electrons in 1 ampere is equal to 6.24 times 10 to the power of minus 18, and we can correlate it, of course, to the Avogadro's number. You see, this is 6.2. You see, so this is column. First of all, the capacitance. If you see, the defibrillator is an instrument which collect the electrical current and release it in a fashion way. It's been released in a way so that it can create a non-defibrillating effect. The key component, of course, is the capacitor. We have the most important is the capacitor, where it collects the current and then it releases this. So the potential, whenever it's 5,000 applied across the place of the capacitor. A capacitor is, of course, two conductors separated by an insulator. This potential in this capacitor creates a amount of electricity which equals 160 millicoulomb. So these two figures ought to be memorized, because whenever I multiply both of them, we will create the energy required to use this defibrillator. Of course, the potential, as we said before, the potential equals the power in watt over the current in ampere. You see, this is the potential that we had mentioned before. I'm sorry. So whenever I want to replace this, I say that the volt equals joule per second over coulomb per second. If we remove the seconds, and then we'll find at the end result that the joule, which is the energy required, equals the coulombs time the volt. In the new version of the book, of course, they show that the energy required, the extra energy required, is the volt time the extra amount of electrical current required. So this is the equation, you see. So whenever I replace this equation, we reach to the final equation that by integration, that the energy equals half time 180 millicoulomb time 5,000 volt, which will yield 400 joule. And this is the amount required during defibrillation. We always use in monophasic types of ventilators a half, I'm sorry, 360. When we use the monophasic, which the biphasic, I'm sorry, which goes into wave two direction, we use less than that, half of this amount. Of course, this is beneficial because it induces less energy, and this harmful to the patient. During this current pulse, it yields 33 ampere for 3 minutes, which gives a synchronized contraction of the myocardium. There is, of course, an inductor. This inductor, as we know, it's nothing than a wire, and this inductor it creates the time of the type of the way required and controls the pulse. Of course, not all this energy is being given to the patient, but part of it is being stored in this inductor. Electrostatic charge are these charges, are charges that are created not through only capacitors, but are created also in bobbin. Whenever the bobbin goes on upwards and downwards, moving through the tubes, of course, this friction creates static electricity, which can, of course, as we said before, is a source of agitation. A capacitor and inductance interference, we will show a figure bigger than that, is the presence of an inductor, which is a wire in the course of an ECG can cause what we call interference. On the other hand, if we have a bulb of light and we have the patient, this both of them creates a capacitor where the 50 hertz of the current voltage can pass through this gap because we created a capacitor. This capacitor, of course, can cause interference of the ECG current. Also, whenever we have an inductor, which is a piece of wire in the course of the ECG, also it can induce a problem. This is why we use what we call screening. Screening means that I am averaging the repeated current. You see, what's the meaning of that? That suppose we are going to come to what we call the signal noise ratio. The signal noise ratio is I want the signal to be potentiated, not on the not affected by the noise. The noise is we're giving to the unwanted signals. You see. So we call what we give screening. Screening means that I'm averaging the repeated signal. The repeated signal ECG is going in a repeated way, and I average the diathermy signals or whatever interfering ECG to zero. So this is a way where how can I lessen the noise signal ratio. Of course, we have another way by using a filter. So this is a way to increase the signal potency. I forgot to tell you that, of course, capacitors are easily to transfer alternating current. On the other hand, direct currents, whenever they go to the capacitor, they go for a certain period till they fulfill their amount in the capacitor, and then the current is being cut off. This, of course, is not the case in what we call the alternating current. The farad is the capability of the capacitor to collect the electrical current through a certain volt. You see, so it is a matter of volt over the column. The relation between the column and the volt will create the capacitor capability. You see. Of course, in the defibrillator, the energy required, as we said, it's the time, the volt time the column, is the energy required to transfer the electrical quantity between the two plates. So it is a matter of the volt and the columns. Of course, as we know, the resistance, which is the ohm, and the ohm is so well known, of course, is the resistance by 1 ampere with a potential difference of 1 volt creates what we call the ohm. Of course, temperature and stretching the wire has an effect on the resistance. The resistance are measured by what we call Watson bridge. Watson bridge is made of 4 arms. where R1 over R2 equals R3 over R4. Of course, this circuit equality comes from a sort of energy, which is a battery, and a voltmeter. This creates what we call a null deflection. If R1 over R2 equals R3 over R4, this is a null deflection. What's the meaning of that? That the pointer in the voltmeter is reads zero. It's an equal circuit. So the circuit is based on, suppose I want to estimate the resistance of a thermometer. I apply it on R3, and I have what we call a rheostat or a changeable resistor in R4. So whenever this circuit is configured, we'll find that the pointer will change. So whenever I change this rheostat or the changeable resistors to a certain certain area, you see, I can notice how much the resistance which was applied created the difference. You see? And another way, of course, of measuring also this resistance, as we can see from the figure, we have 5 resistors, and they are applied through a potential. Of course, these 5 resistors are equal. So whenever I try to find the potential, suppose between 2 of these 5, definitely it will be 20% of the total. You see, as long as they are equal. Of course, if we want to notify the unknown resistance, we can put it in one of these 5, and then we can correlate it to the normal variation. As we said before, if 2 of them, the difference potential is only 20%. If this is different, we can figure out the resistance. This picture showing the isolating capacitor, which is not present in the new versions of the book. This is an internal capacitor where it helps the patient from electrical caution in case a mistake happens during the connections. Now we come to the impedance. Impedance is a word giving instead of resistance. Resistance is not affected much by frequency, but impedance is correlated to the frequency. We give the letter of Z for it. As we can see from this figure, we have, of course, the electrodes, which are made of mainly of metal, surrounded by flange and adhesive material. If they are not well lubricated and away from the skin, it creates a high resistance, and it will attenuate the signal. Of course, the better thing is to, of course, the equipment which reads the ECG has also a resistance. We call it Z apparatus. Whenever it's better for me to increase the resistance of the impedance of the apparatus on the expense of the electrodes to improve the signal and lessen the harmful electrical caution which can happen. Of course, whenever there is moist in the skin, of course, it will enhance the transmission, and this is a method to measure the sympathetic activity. Of course, when you have a sympathetic activity, we have more moist skin, and we can measure it by difference in resistance. I forgot to tell you what's the meaning of screening. Screening, it is a method where the electrodes, ECG electrode, are being surrounded by a woven metal material. This material surrounding the normal electrodes is earthed. So whenever there is interference and we call it inductive coupling, يعني coupling of induction, which will affect the ECG tracing. This woven metal area around the ECG will take the unwanted or the noise signal to the ears, leaving the normal signal of the ECG. I hope that I accomplished my mission. It is a source of knowledge. You ought to know what's the meaning of electricity. And I hope that I'll see you later on. Wassalamu alaikum wa rahmatullah wa barakatuh.